Hello, my dear students of third prep. Today we are going to have a new lesson, which is the distance between 2 points. I wish that all of you understand it, and I wish all of you to listen and look carefully at our examples. Let us start. A, 1 and 2, B, 5 and 2. We want to plot these 2 points graphically. So you are going to draw the x-axis and the y-axis and plot the point A, 1 and 2, and point B, 5 and 2. And join them together. You are going to obtain AB line segment. So, to find the distance between A and B, try to count how many units are there between A and B. It is 1, 2, 3, 4 units. So in this case, we can say that distance between A and B is 4 units. How did you get them? Yes, look carefully. You are going to notice that you subtracted 1 from 5. So in this case, we can say that AB equals absolute 5 minus 1 to give a result as 4 units. You have subtracted, yes, 1 from 5, which is the x coordinate in A and the x coordinate in B. And in this case, AB will be parallel to the x-axis. Let us have another example. A equals 4 and 2, B 4 and 5, and I want to plot these 2 points graphically. So draw the x and the y axes. Try to plot point A and point B. And join AB to obtain a line segment AB. What about the distance between A and B? Try to count them with me. Yes, it is 1 unit, 2 units, 3 units. So we can say that the distance between A and B is 3 units. And you are going to notice that 5 and 2 subtracted from each other will obtain 3. What about 5 and 2? It is the y coordinates of the points A and B. And in this case, we can say that AB equals absolute 2 minus 5 to obtain a result as 3 units. The previous example, you subtracted the x coordinates. In this example, you subtracted y coordinates. The previous one, the x coordinates, it was parallel to the x-axis. So when you subtract the y coordinates, this means that this line will be parallel to the y-axis. Then, to find the distance between 2 points A and C. If you have the point A, x1, y1, B, x2 and y2, try to find the distance between A and B. How can you find it? First of all, you are going to plot point C and try to draw the 2 perpendiculars. You are going to notice that AC is parallel to the x-axis, so it is x2 minus x1. And also BC parallel to the y-axis, so it is y2 minus y1. This means that the distance between A and C will be x2 minus x1, and the distance between B and C will be y2 minus y1. Can you find the distance from A to B? Yes, by using Pythagoras theorem. So, AB to the power of 2 equals x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. Then to find AB, you are going to take the square root for both sides. So you are going to obtain AB equals square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. And this is going to be our rule. To find the distance between 2 points, you are going to find it by the rule square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. And here you are going to notice that the distance between any point and the origin. What about the origin? Its coordinates are 0 and 0. So the distance between any point and the origin will be square root x1 to the power of 2 plus y1 to the power of 2. Now let us have some examples. Distance between the point 3 and 4 and the origin equals how many units? You know that the rule to find the distance equal square root x1 to the power of 2 plus y1 to the power of 2. What about x1? It is 3. So square root 3 to the power of 2 plus y1, which is 4 to the power of 2. To obtain a result as square root 9 plus 16. And this will lead us to square root 25. So the distance will be 5 units. Another example, distance between the 2 points -5 and 0 and 0 and 12 equals how many units? To find the distance between these 2 points, try to write x1, y1 for the first point and x2, y2 for the second point. And then try to find the distance by using the rule. So the distance will be square root 0 minus -5 all to the power of 2 plus 12 minus 0 all to the power of 2. And this will lead us to square root 25 plus 144, which is equal to square root 169. And this will lead us that the distance will be 13 units. Another example, if the distance between the 2 points A and 0 and 0 and 1 is unit length, then A equals what? What does this example means? It means that the distance between the 2 points A and 0 and 1 is a unit length, 1 unit length. Is unit length means 1 unit length. So the distance will be 1. Then try to substitute in the rule. Distance equals square root 0 minus A all to the power of 2 plus 1 minus 0 all to the power of 2, which is equal to square root A to the power of 2 plus 1. This distance is going to be equal 1, as the distance between the 2 points is 1. This will lead us by squaring both sides. You are going to find that A to the power of 2 plus 1 equals 1. Yes, then A to the power of 2 equals 1 minus 1 equals 0. By taking square root for both sides, you are going to find that A equals 0. Another example, the radius length of a circle whose center is 7 and 4 passing through the point 3 and 1 equals how many units? The center of the circle is the point 7 and 4. And what does the circle passes through the point 3 and 1? It means that the point 3 and 1 is lying on the circumference of the circle. So what about the radius length? It is the distance between the circle and the center of the circle. So it is square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2, which is equal to, by substituting, square root 7 minus 3 all to the power of 2 plus 4 minus 1 all to the power of 2. Then what about 7 minus 3? It's 4 to the power of 2 is 16. So it is square root 16 plus 4 minus 1, 3, power 2 equals 9. So it is root 16 plus 9, which lead us to square root 25. And this means that the radius length will be 5 units. So the radius will be 5 units. Let us have another example. ABCD is a quadrilateral where A is 2 and 4, B negative 3 and 0, C negative 7 and 5, and D is negative 2 and 9. Prove that ABCD is a square. First of all, we are going to find the length of AB, or the distance between A and B. It is square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, it will be square root negative 3 minus 2 all to the power of 2 plus 0 minus 4 all to the power of 2. This will lead us to square root 25 plus 16, which is equal to square root 41 units. This is the length of AB. What about the length of BC? BC equals square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, you are going to find that square root negative 3 minus negative 7 all to the power of 2 plus 0 minus 5 all to the power of 2. This will lead us to square root 16 plus 25, which gives square root 41 units. Then what about the length of CD? It is a square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, it is negative 7 minus negative 2 all to the power of 2 plus 5 minus 9 all to the power of 2, which is equal to square root 25 plus 16 equals square root 41 units. And this is the length of CD. What about the length of the fourth side? It is AD, which is equal to square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, you are going to find that square root 2 minus negative 2 all to the power of 2 plus 4 minus 9 all to the power of 2, to obtain a result as square root 16 plus 25, which is equal to square root 41 units. In this case, you are going to notice that AB equals BC equals CD equals AD equals square root 41 units. Here, the four sides of the quadrilateral are equal. This quadrilateral may be rhombus and may be square. Then, to identify whether it is a square or a rhombus, you must find the length of the two diagonals. If they are equal, so the figure will be square. If they are not equal, so the figure will be rhombus. Then, what about the diagonals? AC, the first diagonal, it is a square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. So it is a square root negative 7 minus 2 all to the power of 2 plus 5 minus 4 all to the power of 2, which is equal to square root 81 plus 1 equals square root 82 units. And this is the length of the first diagonal, AC. What about the second diagonal? It is BD. So it is square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2, which is equal to square root -2 minus -3 all to the power of 2 plus 9 minus 0 all to the power of 2. The result will be square root 1 plus 81 equals square root 82 units. In this case, you are going to notice that AC equals BD. It means that the diagonals are equal in length. So this will lead us that the figure ABCD is a square. Prove that A, 3 and -1, B, -4 and 6, C, 2 and -2 are located on a circle whose center is the point M, -1 and 2. Then find the circumference of the circle. To prove that the 3 points A, B, and C are located on a circle whose center is M, it means that you must prove that the distance from A to M is exactly the same as the distance from B to M and exactly the same as the distance from C to M, as they will be radii of the circle. So first of all, we are going to find the length of MA. It is square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. So it is square root 3 minus -1 all to the power of 2 plus -1 minus 2 all to the power of 2, which gives square root 16 plus 9, which give a result as 5 units. So MA equals 5 units. What about MB? Exactly the same. Square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, it is square root -4 minus -1 all to the power of 2 plus 6 minus 2 all to the power of 2 to obtain a result as square root 9 plus 16 to give 5 units. So MB will be 5 units. What about MC? By the same way, square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2, which lead us to square root 2 minus -1 all to the power of 2 plus -2 minus 2 all to the power of 2, which gives a result as square root 9 plus 16, which give 5 units. Here you are going to notice that MA equals MB equals MC equals 5 units. Now the 3 line segments are equal in length. This means, and they have a fixed point M inside the circle, so this means that A, B, and C are located on the circle whose center is M, which is -1 and 2. Then to find the circumference of the circle, you are going to notice that circumference of the circle, its rule is equal to 2 pi r. It means 2 multiplied by pi multiplied by the radius. This will lead us to 2 multiplied by pi multiplied by 5 instead of the radius, as the length of the radius equals 5 units. And this will lead us to an answer as 10 pi centimeters. Let us have another example. Prove that A, 4 and 3, B, 1 and 1, C, -5 and -3 are collinear. To prove that 3 points are collinear, you must prove that the sum of length of 2 line segments of them equals the length of the third one. So we must find the length of AB. What about AB? It is square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, it is square root 4 minus 1 all to the power of 2 plus 3 minus 1 all to the power of 2, which is equal to square root 9 plus 4 equals square root 13 units. What about BC? BC equals square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2, which is equal to square root negative 5 minus 1 all to the power of 2 plus negative 3 minus 1 all to the power of 2. This will lead us to the result square root 36 plus 16, which is equal to square root 52 units. What about the length of the third side? It is AC. So what about AC? It is square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2, which is equal to square root 4 minus negative 5 all to the power of 2 plus 3 minus negative 3 all to the power of 2, which give a result as square root 81 plus 36, and this will lead us to the result square root 117 units. Now try to add the smallest two sides, which are AB plus BC. What about AB? Square root 13. Plus, what about BC? Square root 52. So by adding them together, you are going to obtain a result as 3 square root 13 units. This is the sum of the two small sides. Then what about AC? AC equals root 117, which is equal to 3 square root 13 units. Here you are going to notice that AB plus BC equals AC. And this means that A, B, and C are collinear. Let us have another example. Prove that the triangle whose vertices are A, 5 and negative 5, B, negative 1 and 7, C, 15 and 15, is right angle triangle at B, and then find its area. First of all, we are going to find AB to the power of 2. Instead of writing AB equals square root, we are going to write AB to the power of 2. So it is equal to negative 1 minus 5 all to the power of 2 plus 7 minus negative 5 all to the power of 2, which is equal 36 plus 144 to obtain a result as 180. Then what about BC to the power of 2? Yes, it is equal to 15 minus negative 1 all to the power of 2 plus 15 minus 7 all to the power of 2, which gives a result as 256 plus 64 equals 320. What about AC to the power of 2? It is equal to 15 minus 5 all to the power of 2 plus 15 minus negative 5 all to the power of 2, which gives a result as 100 plus 400 equals 500. And this means that AB power 2 plus BC power 2 equals 180 plus 320 to obtain a result as 500. Then what about AC to the power of 2? It is equal to 500. What do you notice? You notice that AC to the power of 2 equals AB to the power of 2 plus BC to the power of 2, which is Pythagoras theorem. In this case, we can say that triangle ABC is right angle triangle at B. Then what about area of triangle? Area of triangle ABC equals half times base times height. What about the base and the height? Yes, the base is AB and the height is BC, as they are perpendicular. So it is equal to half times AB times BC. Then it is equal to half multiplied by, what about AB? Square root 180. What about BC? It is square root 320. By finding their product, you are going to obtain an area as 120 squared units. Now, let us have another example. If the distance between 2 points A and 7 and 3a minus 1 and negative 5 equals 13. Find the value of a. Now, try to find the distance between the 2 points, and you are going to equalize them by 13. How? Distance equals square root x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. By substituting, you are going to find that square root 3a minus 1 minus a all to the power of 2 plus negative 5 minus 7 all to the power of 2. Then, by substituting, instead of the distance, you are going to write 13 equals square root. What about 3a minus a? It's 2a minus 1 all to the power of 2 plus negative 5 minus 7 means negative 12 all to the power of 2 give 144. By squaring both sides, you are going to find that 169 equals 2a minus 1 all to the power of 2 plus 144. This means that 2a minus 1 all to the power of 2 equals 169 minus 144 to obtain a result as 25. This means that 2a minus 1 all to the power of 2 equals 25. By taking square root for both sides, you are going to obtain 2a minus 1 equals positive or negative 5. This means that 2a minus 1 equals 5 and 2a will be equal to 5 plus 1 gives 6, so a will be 3. And in another way, you can find that 2a minus 1 equals negative 5. So 2a equals negative 4. By dividing both sides by 2, you are going to find that a will be negative 2. Now, by the end of this example, we reached the end of our lesson today.